progressions for class 10th. We will be also learning to find the general term of a geometric progression and and also the nth term from the end. We will be also solving problems regarding the same. Now, to start with geometric progressions, note that geometric progressions are not arithmetic progressions. Let us take a few examples to understand this. You have three sequences, say 3, 27, 2, 4. Consider these three sequences. Now when I said that geometric progression is not an arithmetic progression, it means that if we take the difference between these two, we see that the difference is not the same throughout. Similarly, in the next sequence as well, the difference between these two terms is not the same. Same to this one. So it means that these sequences are not arithmetic progressions. But for these sequences to be a geometric progression, the ratio between the two terms has to be the same and it has to be constant throughout. Let us take here in the first case. The common ratio between these two terms is 3. Similarly, in these terms, it is 3 and so on. So the common ratio is 3 in the first sequence. In the second sequence, we see that the common ratio is 2. Whereas in the final one, the common ratio is x. Now, the common ratio is denoted by the letter r. Now, in a geometric progression as well, the first term is denoted as a, second term as a1, third term a2, a3 and so on. So the common ratio for a geometric progression is calculated when you take the ratio between the second term and the first term, that is a2 divided by a1. So if this is the same throughout, it means if the common ratio is the same throughout, then it means that that sequence is a geometric progression. Now if we now notice that the next term in a geometric progression is obtained when you multiply the ratio, that is this 3 to the preceding term. So to obtain the second term, you are multiplying it with 3. And then similarly in the next case, 9 into 3 is 27. So the standard geometric progression will be a, that is the first term. Second term is obtained when you multiply the common ratio, that is ar. Similarly, the next one is when you multiply to this term the common ratio, which will be ar square and so on. So this is the standard geometric progression which has the common ratio r. Now if you have to calculate the 10th number, you have to calculate the number in the 10th position, or so you have to find the 30th number or the number in the 30th position, then that is denoted by the general term which is denoted by an. Since in a geometric progression, the second term is multiplied by the first one, the nth term is given by ar raised to n minus 1, where a and r are multiplied. Where a is the first term, r is the common ratio, n is the number of term, and an is the nth term or the general term. In a geometric progression as well, if it is a finite sequence, say with the last term given, then the last term is taken as the nth term. Now if you have to calculate the nth term from the end, then the standard geometric progression is ar square, say the last term, and since it is a decreasing sequence now, so you will be dividing it by r, and the next one will be lr square and so on. So if you are calculating the nth term from the end for a geometric progression, the nth term formula is given by, instead of a, it will be replaced by l, and it will be divided by, because it is decreasing now. So from the end, then the same term remains as it is. So using these three formulas, we will solve exercise 11a from the textbook. Let us consider the third problem from exercise 11a, wherein first step is you have to show that this is a GP, that is geometric progression. To show that this is a GP, we have to see if the ratio is constant throughout. So how do you calculate the ratio? It is the second term divided by the first term, which when you cancel, I get it as negative 1 upon 3. Notice that the negative sign is in the denominator, but when you are writing it, that negative sign is common to both the numerator and the denominator. Let us check for the next one. The second term over here is minus 3 divided by 9, which is also same, and you will get it as minus 1 upon 3. Let us check for the next one. 1 upon minus 3 is same as negative 1 upon 3, and similarly negative 1 upon 3 divided by 1 is same as negative 1 upon 3. So therefore it means that it is a GP. The next step in this question is to calculate the first term. The first term is denoted by A, which is nothing but negative 27. The second thing is to calculate the common ratio, which is denoted by R. R is nothing but the second term divided by the first term, which is negative 1 upon 3. The next thing is you have to calculate the nth term. The nth term we will be using this formula. So you have an is equal to ar raised to n minus 1. Nth term meaning we have to find, you will substitute for a and r. So a is minus or negative 27, r is negative 1 upon 3, the whole raised to n minus 1. Now in the geometric progressions we will be using the laws of indices that you have learned in class 9. Now in this case you see that 27 is a multiple of 3, so you reduce 27 in terms of 3, which would be negative 3 the whole cube, and this will be 1 upon minus 3 the whole raised to n minus 1. Now when I get this negative 3 the whole cube in the denominator, the sign of the index will change. So I will have 1 upon negative 3 the whole raised to negative 3. Note that here 1 raised to n minus 1 is 1 always. That is n raised to anything is 1. That is divided by minus 3 raised to n minus 1. Now here we use another law of indices, which is a raised to m into a raised to n is equal to a raised to m plus n. When the base is the same, you can add the index or the indices. So that will be 1 upon minus 3 raised to n minus 1 minus 3 is n minus 4. This is equal to an. The final question, part of this question is to calculate, and this is the third. The final part is to calculate the ninth term. So in this nth term I will be replacing n by 9. So I have 1 upon minus 3 raised to 9 minus 4, which is 1 upon minus 3 raised to 5. This you can use again the same law, and you will have it as 1 divided by minus 3 raised to cube multiplied by minus 3 square. This is negative 27 into 9, which is 1 upon minus 243, which is same as negative 1 upon 243. Let us consider another example, problem number 9. Which term of the GP is 729? It means that this is the last number that is given, and after this there is no number mentioned. So let us write this as, so this is root 3, 3, 3 root 3, 9, and so on till 729. So which term, meaning they are asking you what is the position of this number in this sequence. That is, since this is a finite sequence, remember this will be the nth term, that is 729. The position of this number will be to calculate n here. So we are supposed to calculate n. We know a is equal to root 3, and we know r is the second term divided by the first term, which on rationalizing, when you rationalize this, root 3 will be multiplied both the ways to give you root 3 as the answer. Okay. Now using this, Using the nth term formula, let us calculate n. So an is equal to ar n minus 1 for geometric progressions. So nth term is nothing but the last term, which is 729. The first term is root 3. The ratio is also root 3, the whole raised to n minus 1. Now the index for this root 3 is 1. So using the laws of indices, when you have the same base, you add the index. So this will be root 3 raised to 1 plus n minus 1. So minus 1 and plus 1 will cancel, and you have 729 is equal to root 3 the whole raised to n. Now the same laws of indices, to calculate n, you have to reduce 729 as root 3 and get the power of it. Now how to do that? Now 729 is nothing but the square of 27. You can again reduce 27 because that is the cube of 3. So 3 cube the whole raised to square. So when you have the same base and the indexes are multiplied, it means it will be 3 raised to 6. 3 can be again reduced in terms of root 3 as root 3 the whole square and the whole raised to 6. Because we know when root 3 is multiplied 2 times, you get it as 3. So therefore this will be root 3 the whole 12. So therefore in this statement, so therefore 1 is, in place of 729, I will be writing root 3 the whole raised to 12. This is 729 is equal to root 3 the whole raised to n. Now since the bases are the same and they are equated, this implies that the indices are also the same. So which term of the AP is 729? It means the position of this number in this sequence is 12. So that is A12 is equal to 729. Let us consider another example, problem number 12. You have to find a GP whose 4th and the 7th terms are 1 upon 18 and negative 486, 1 upon 486. Now in this case, to find the GP, the standard GP is given as, so therefore the GP is, let the GP be AR square and so on. So in this, what is the terms that are missing? You have to calculate first what is A and you have to calculate the common ratio. Now you are given two conditions here. The 4th term is 1 upon 18, so that is denoted by A4 is equal to 1 upon 18, and you are given that the 7th term, that is A7 is equal to negative 1 upon 486. So using both of these conditions, you will be first calculating the first term and the common ratio. So using the nth term formula, using the an formula here, a r raised to 4 minus 1 is equal to 1 upon 18, which will be a r cube is equal to 1 upon 18. Let this be equation 1. Similarly, a7 will be a r raised to 7 minus 1, which will be 6, equal to negative 1 upon 486. Let this be equation 2. Now how do we solve both these equations? Let us check which among this equation has the highest power. The highest power is this one, so you take the ratio between the highest power equation and the lower one. So you have ar raised to 6 divided by ar cube is equal to negative 1 upon 486 divided by 1 upon 18. Here a and a will cancel, and here using the laws of indices again you will get r raised to 6 minus 3 because the bases are the same. This will be negative 1 upon 486, and for the second one you take a reciprocal. So you have this to be as 18. So this will be r cube will be equal to, so you cancel this, so I have 9 2 4 54. This again reduces to 27. This is nothing but 1 upon 27. R cube is equal to negative 1 upon 27. Now when you are taking the cube roots, R will be equal to, irrespective of the negative sign, I have 1 upon 3. And when you have a cube root, the negative sign comes down as it is. If there was a square, you couldn't take the square root, but for cube root, it is valid. So for cube root, you directly take the cube root and the sign, whichever is there, comes as it is down. So therefore, R is equal to negative 1 upon 3. Substituting this value in any one of these equations, in which I will be substituting in equation 1. So substituting R equal to negative 1 upon 3 in 1, I get R is 1 minus 1 upon 3 the whole cube equal to 1 upon 80, which is negative 1 upon 27 is equal to 1 upon 80. So here you can cancel the denominators, 9, 2, 3. Therefore, A will be equal to, cross multiplying it, I get negative 3 by 2. So we have calculated the first term and the common ratio. The thing is, you have to calculate the GP. So therefore, the GP will be the first term. Then the second term is, you multiply the ratio to the first term. When you are multiplying the ratio to the first term, the negative and the negative sign will become positive when you multiply, and 3 and 3 will cancel to give you half. To obtain the next, that is the third term, you have to multiply the common ratio to the second term again. So which when you do, you get negative 1 upon 6 and so on. In problems like this, when you are told to find the GP, the minimum number of terms you can take is 3 and continue. So this is the answer. Let us consider another example, problem number 15. You have to find the fourth term from the end. From the end meaning we will be using this formula. That is, you have to calculate the fourth last term. So for this is again a finite series. Now in this, A, the first term is 2 upon 81. R is the second term divided by the first term, which you take the reciprocal of which, so I get 81 divided by 2. Note that I am doing the step in the same step itself. So cancelling this, 27 1 into 3. Therefore, R is equal to 3. In this formula, so now we have R. What else do we need? We require the last term, which is given. So therefore, L is equal to 54. So therefore, the fourth term from the end will be A4 from the end is L divided by R raised to 4 minus 1. In place of N, I write it as 4. So L is 54 divided by R is 3 raised to 3. Know that for when you're using the index, please use brackets. So now when you're doing prime factorizations, this will be reducing to 27 into 2. 27 into 2 is 54 divided by 3 the whole cube. Now 3 cube is nothing but 27, which will cancel to give you 2. So therefore the fourth term from the end is 2. Now in such problems, please don't divide it with the ratio to get the fourth term. Use the formula. Let us consider another problem, problem number 13. For what value of x the numbers, you are given 3 numbers here, which is x plus 9, x minus 6 and 4 are in GP. So you have to find the value of x for which these numbers are already in GP. If they are already in GP, meaning the ratio between the two terms has to be the same. So let us consider the ratio between these two terms, and these two terms have to be the same, which will be the second term divided by the first term is same as the ratio between these two, wherein 4 is the second term and the first term here is x minus 6. Now to calculate x, I will be cross multiplying it. So when I cross multiply, I get x minus 6 the whole square, since both of these are similar, and this will be 4 into x plus 9. Expanding this bracket, so I have x square plus 36 minus 12x is equal to 4x plus 36. So you can cancel 36 and 36. So I have x square minus 12x is equal to 4x. So getting the 4x on the other side, it would be negative 4x. So minus 12x minus 4x will be minus 16x is equal to 0. Now when you reach at such place, please don't make the mistake of cancelling the variable x here. You take out a common factor, which is x itself, and that will be x minus 16 equal to 0. So equating both to 0, I have x is equal to 0 or x is equal to 16. So therefore there are two values of x for this problem. So either x is 0 or x is equal to 16. In today's video we have learned geometric progressions, and we had learned to find the general term and the general term from the end. Using the problems or from the problems that we have solved in this video. So try to solve exercise 11A from R.S. Agarwal. Thank you.